slap this. There we go. Here's the noise I love.
There we go.
I didn't say it.
Everyone's just raising because I have
Yeah, there we go. So just one bar stats, and then just stick an L6 after it. L6, you get it how?
Second 6.
Boom, Monica, thank you. Second 6, any list you ever need, second in that number. Boom, enter, and here's all the goodness from yesterday. There's our average of about 17. Looks like we've all told been to 488 states, which doesn't make any sense as you realize we've all been to Oregon, obviously. I don't know what that means. That's a square, so it doesn't mean anything anyway. There's your plus or minus a 10. So this is the screen we're kind of ignoring right now. It doesn't make a whole lot of sense to talk about it a lot because we've got a little bit of skew, and we're kind of nervous about that average being a little high. Now, has anybody concerned themselves with this question? So we've got a little bit of skew. What constitutes? Maybe I'm not thinking about it yet. It's good to not worry about it. What constitutes too much skew? Like when would it be too far past a bell shape to be like, no, that is not. I'm going to generate a data set with you guys in a little bit. I think that will be, it usually does anyway, patently obvious, like no way in hell that's a bell shape. That was like an exponential curve. But like this one looks-ish like a bell, especially with the way you guys drew your histograms. Carly?
Usually 2 standard deviations.
Well, the problem is, what's the standard deviation if the data is skewed? Should we even look at that? What you're talking about, and thank you for this, is you're talking about how to identify unusual data points. I'm talking about how to identify an entire data set that's leaning too far to one side. Is that fair?
Yeah.
What you just said is perfect. Outside of 2 standard deviations, we call kind of weird, unusual, too far out. But how do we know if a data set should even use a standard deviation or if it's too skewed? What do you think, Jolene?
Well, for this one, our standard deviation is 10, so that would knock us down to right around 7 states. And if we go out another standard deviation, which I'm going to assume is going to be lower than 10.
Which would be negative then, right?
Yeah, and you can't have a negative state.
Don't ever get, that's a very good point, thank you, Jolene. If you start applying 2 standard deviations like Carly said, 2 standard deviations would be about 20. If you try to take 20 away from average, you fall into the negative realm. That's okay, because you're applying a mathematical principle to a contextual data set. And all that means, realistically, is that nobody's been to too few states. And I love that you just said that. We're going to come back to that, I promise. But that doesn't stop us. We have to stop before that maybe. When should we even consider not using the standard deviation at all? Now, this is a loaded question, first of all. The best thing we did last time was we drew the histogram stat plot on, let me turn the histogram on and get it on L6. Okay, and we drew a histogram like that, and we said, ooh, it's kind of leaning. It's kind of got this tail that's going off to the side. But the question is that non-bellish enough? If you want a numerical answer, and this is an if you ever need a numerical answer, in the homework for variation, I put a section on something called Pearson's second skew coefficient. It's a command called skew in Excel, and there's also something I put in variation that assigns a number based on the relative comparison of the mean, the median, and the standard deviation. It checks for a difference between the mean and the average, as ours is different, yes. Ours is different. It was 17, hang on a second, 17 to, go down, oh, I gotta rerun it again, sorry. Our average is 17-ish, and our median was 14. So that's a difference of about 3 states, and then our standard deviation was about 10. So it takes the 3, divides it by 10, calls it 0.3. That number doesn't really have a unit anymore. They've all been divided off. But that 0.3 gives you an idea of skew. As that number gets bigger, the data gets more skewed because the median and the average are pulling away from each other. As you develop more and more of a tail, the average wanders towards it, but the median stays put. So the skew itself, and the standard deviation is getting bigger as well. If you're interested, this is a big if. You also can say, you know what, that's great, I'm going to shelve that. In case I ever take a class where I need to worry about that, I know where it is. And please realize your homework sets and all this stuff is up forever. It's yours forever. Please, Carly.
Well, I don't think, it seems like that wouldn't accommodate for what the data points actually were, because if you had a range from 0 to 500,
yes,
then you could still have the same skew.
You very well, as a data set from 0 to 50. That's very, very true. That's why.
You apply
That's why well, I took it off now, but that graph we just looked at is probably the best way to decide. Your gut call on whether something is too skewed or not. It's not a very satisfactory answer from American math students. We want to know, give me a fence post. If I get beyond the fence post, I've gone too far. Give me a line in the sand. There really is none. I mean, that Pearson second skew coefficient, this guy Pearson or Hildebrand, whoever it was, I forget who, people, they decided that anything bigger than 0.2 was called skewed. You can argue. So I'm with you, Carly. I'm totally with you. Just realize there's some gray involved. There's some gray involved. So it's better to accumulate tools and then let you guys let it kind of marinate in your mind as you think about it. Cool? Thank you guys for all those. Anyway, speaking of this, what is all this? What is all this? Min, Q1, Mead, Q3, Max. Let's take a look at that for a couple moments here. And I'm going to go ahead and shut the camera down and start it back up again because this is worth talking about. These are very important numbers. Unlike that summation of x squared, which really doesn't mean a whole lot.